Hello students, welcome back to the Tantra physics classes. The lecture series continues on rotational dynamics, and today's lecture is on rotational energy and conservation of energy. Rotational energy I will combine with conservation of energy, because mostly the rotation may be taking place in gravitation, or rotation may be taking place under no external non-conservative forces. Therefore, the mechanical energy should be conserved. As you already know, that if there is force which may be conservative, under that force, the total mechanical energy is conserved. The problem is like this. It is a rod in the vertical position of length L. It falls. We give it a slight push so that it falls. It falls about this point O. That means this point O does not move. It falls like this. That is, it rotates about point O and then it falls. When it falls onto the ground, we have to find what is the velocity of this point P, the end point of the rod. Is point ka kya velocity hai when it hits the ground? That is all. So what we do? Obviously, the rod is rotating about this point, and the rod is falling under gravity, and gravitational force is a conservative force, and under all conservative forces the total mechanical energy is conserved. So first of all, what we will do, we will find the total mechanical energy when the rod was in the erect position, and we will find the energy when the rod falls onto the ground and hits the ground. At that time, the total energy here and here must be the same. So what is the energy when the rod was in erect position? Energy E1, initial energy, that is mg h. But what is h? H is what is the position of its center of mass? That is L by 2. First equation. When rod falls onto the ground, it has pure rotational energy about this point, because when the rod is flat on the ground, the total potential energy will be zero, because it is just flat on the ground. So E2, here it is potential energy, okay, plus kinetic energy, that is zero, because when it was in the erect position there was no kinetic energy. But now when it falls on the ground, potential energy is zero. But what is this rotational energy? It has pure rotation about this point, that is 1 by 2 I omega square. Equation second. As the external force is only gravitation, therefore E1 is equal to E2. Total energy is conserved. Initial and final energies are the same. So mg L by 2 is equal to E2, that's 1 by 2 I omega square. That is mg L by 2 is equal to 1 by 2. What is moment of inertia of this rod about this point? That is 1 by 3 m L स्क्वायर इंटू ओमेगा स्क्वायर. तो यहां पर क्या करेंगे, 2 और 2 कैंसिल होगा, ये m कैंसिल होगा, एक 1 स्क्वायर के साथ कैंसिल होगा, तो हमें मिलेगा ओमेगा यहां से एंगुलर वेलोसिटी अबाउट पॉइंट ओ, दैट विल बी 3g by L, but root. This is the angular velocity of this rod when it hits the ground. So what is this V? V is this L into angular velocity, L omega, right? That is the rule that we have. Velocity here is omega into the distance from the point of rotation, from the point about which it rotates. So V is equal to L is L, hence the root of 3g by L. So it will be V equal to root of 3gl, because L will go inside as L square, 1 L will cancel. So it is root of 3 into 10 into this L is 1 meter, 1, that is root of 30, answer. So the speed of this point when it hits the ground will be root of 30. This is problem number 1. Let me go to the problem number 2. This is the second problem. The problem is like this. It's a rod, simple rod of length L and mass m. Mass is m. It rotates about the end. I mean, about one of its ends, it rotates in a circular motion. And it makes f revolutions per second means f is the frequency. F is just the frequency, not angular frequency. F is frequency, but we know omega is 2 pi f. Angular frequency is 2 pi into frequency of the object. Okay. So this rod makes f revolutions per second. We have to find what is the rotational energy. Obviously, it rotates about the endpoint, and moment of inertia has also to be found about this axis, right? It rotates like this. So it has a simple formula. K rotational is equal to 1 by 2 I omega square, as you must be knowing. Rotational energy is the same counterpart of 1 by 2 mv square. 1 by 2 mv square is the translational kinetic energy, and 1 by 2 I omega is the rotational kinetic energy. And total energy of a body which is rotating and translating is sum of the two. If a body is only spinning about its center of mass, it has rotational energy. 1 by 2 I omega square. I is the moment of inertia about the center of mass, omega is the angular velocity. But if the body is rotating and translating also, moving in the like this, it is rotating and translating in the forward direction. So in that case, what is the total energy? The total energy is kinetic translational plus kinetic rotational. That is 1 by 2 mv square plus 1 by 2 I omega square, sum of the two. But here the rod has a pure rotation about this. Oh, therefore it has only rotational kinetic energy. So this 1 by 2 I omega square. So K rotational is equal to, that's 1 by 2 I moment of inertia about the end point, that is 1 by 3 ml square, if you remember, omega square, that is 2 pi f whole square. So it is K rotational 1 by 2 into 1 by 3 ml square 4 pi square f square. It is 2, 2, 4. So what is the final answer? Final answer is K rotational is equal to, that is 2 by 3, this 2 by 3 ml square, okay, pi square f square. Answer. Let me go to the third problem. Here is one more problem. Here is a body which rolls down the incline, and when it comes at the bottom of the incline, it has velocity v, and it falls from height h, rolling down. But initial velocity was 0. It was not initially rolling, but it rolls down, and finally it has velocity v, translation velocity. But it is also rolling. It is also rolling with omega, and it has a translation velocity also. The question is, what is its velocity when it reaches the bottom of the incline? That is our question. A body rolls down the incline and reaches the bottom, and what is the velocity when it reaches the bottom? But at the bottom position, it has two energies, translational kinetic and rotational kinetic energy, because it is rolling also, rolling and moving forward. So this body falls down to the ground under gravity, and gravity, as you know, it is a conservative force, and the total mechanical energy will remain constant, right? So what is the energy at the top position? The energy at the top position, E1, let me suppose, is mgh. That is potential energy, of course, from the ground position, and plus kinetic energy, that is 0. Equation first. When the body reaches the ground, what is this energy? That is mgh, the potential energy is 0. Potential energy is 0, plus kinetic energy is 1 by 2 mv square, plus rotational energy is 1 by 2 I omega square. Second equation. So what should we do now? We have to conserve the energies, because total energy has to remain constant. The initial energy is equal to final energy. Initially it was totally potential energy, but finally when it goes onto the ground, it has total kinetic energy. But two forms of kinetic energies, translational kinetic energy and rotational kinetic energy. ठीक? So what should I write? क्या लिखना चाहिए मुझे? Energy conservation. E1 is equal to E2. That is mgh is equal to, okay, that is 1 by 2 mv square plus 1 by 2 I omega square. But for rolling, you have one more equation. When the body rolls on the ground, not skids, not slips, when it rolls smoothly on the ground, then we have one more equation for rolling condition. V is equal to R omega. The center of mass velocity is equal to radius of that rolling body into angular velocity. That's what we already know. It's a condition for rolling. Condition for rolling. It is condition for rolling. So what should we do here? Now mgh is equal to 1 by 2 mv square plus 1 by 2 I omega square को लिखो v square by r square. Right? Now let me do it like this now. mgh is equal to, okay, 1 by 2 v square mv square कॉमन निकालेंगे हम. अंदर क्या रहेगा इसके 1 प्लस यहाँ क्या रहेगा 1 by 2 कॉमन m v कॉमन m is missing here, so it is I by mr square. That is, if we get 1 by 2 mv square common, obviously 1 by 2 mv square here, it will remain 1 here, 1 by 2 is common, v square is common, m is missing, so m has to go to the denominator. This, okay, m gets cancelled. What's v square? That is 2gh divided by 1 plus I by mr square. Okay, and what about v? V equal to root of 2gh divided by 1 plus I by mr square. General formula for velocity. When the body reaches the ground, the general formula is when the body reaches the ground, the general formula is V is equal to root of 2gh divided by 1 plus I by mr square. This is the formula. Now, if it is a disk rolling down, you can write the moment of inertia of a disk here. If it is a sphere rolling down, you can write the moment of inertia of a sphere. If it is cylinder rolling down, so it's a general rule. So you have just substitute for I for different bodies. One more problem. Okay, this is fourth problem. A body rolling down the incline. Let me find with what acceleration it is rolling down the incline. This is a body, a rolling body. Maybe it is a sphere, maybe it is a disc, maybe it is a ring. It rolls down the incline. I need to find with what acceleration it rolls down the incline. As we already know, if it's a sliding body, अगर body sliding है, तो उसका acceleration है g sin theta. Any body sliding down the incline, its acceleration along the plane is g sin theta if there is no friction. अगर friction भी है तो then g sin theta minus something, because frictional force will oppose. But here the body is rolling down. Obviously there must be friction, otherwise it will not roll down, it will skid. This friction causes the rolling, but we have to find what will be the acceleration of this rolling body down the incline. It's a question. So how to do it? First of all, tell me what is the acceleration. Acceleration is net force. What is the net force? Basically, mg is the downward gravitational force. It is put into two components, mg sin theta, mg cos theta. Mg cos theta will be balanced by the normal reaction. Mg normal reaction pass through the center of mass, therefore these two forces will not create any torque. It is this frictional force which will create about center C. Only frictional force will create torque. So frictional force ही torque create करेगा about C. mg या n या ये दो components वो mg के ही components है, जो mg करेगा वो components भी करेंगे. ये mg और n कहां से पास करते हैं? सेंटर ऑफ मास से पास करते हैं. और जब वो सेंटर ऑफ मास से पास करते हैं, therefore they should not create any torque about that center of mass because they pass through that point. Only frictional force will create the torque about R. तो पहली बात यह है कि what is this acceleration along the plane? That is mg sin theta minus this frictional force. This is downward force, this is up force, F divided by m. वो m यहाँ भी लिख सकते हैं और m यहाँ भी लिख सकते हैं. Equation number first. So I am held up only for this frictional force. How can I find the frictional force? on the body which is rolling down, how much friction is needed for a body to roll down the incline. ठीक, उसके लिए कंडीशन कुछ है. तो पहले मुझे बताइए व्हाट इज टॉर्क. टॉर्क इज F, फ्रिक्शनल फोर्स, and this R, radius of the sphere about C. This frictional force and this R, FR, and this I alpha also. Torque is I alpha also. तो और एक चीज है I, what is alpha? For rolling, I have one more equation for rolling. अगर आपको अभी मैंने बताया कि रोलिंग के लिए V is equal to R omega. If you differentiate acceleration is equal to R alpha. If you differentiate this, so A is equal to R alpha. तो ये alpha जो है for rolling के लिए it is A by R. It is A by R. So मुझे मिला, मैं ये F यहां से निकालूंगा. So what is F equal to? That is I A R, यहां भी R, तो ये R नीचे आकर R स्क्वायर हो जाएगा. तो अब मुझे क्या करना है, इस F को जो फ्रिक्शनल फोर्स मैंने यहां से निकाला, फ्रिक्शनल फोर्स निकालने से पहले मैंने कंडीशन लगाया इट इज रोलिंग है, तो ये इक्वेशन है, तो ये इक्वेशन में मैंने इंसर्ट किया. सो दिस इज द फ्रिक्शनल फोर्स which is needed for rolling, because I have inserted the equation for rolling. Equation for rolling is A is equal to R alpha, right? Okay, now put this here in equation 1. So what should I get? MA equal to mg sine theta minus F, that is I A by R square, right? That is, इसको यहां लाइए, MA plus I A by R square is equal to mg sin theta. ये इसको यहां लिया जब मैंने. So how to do it now? A few more steps. देखिए, यहां MA को कॉमन निकालिए आप. MA अंदर क्या रहेगा, 1 प्लस, यस, MA कॉमन है, A कॉमन है, तो ऊपर रहेगा I, M मिसिंग है तो यहां जाएगा mr square. It is good to write mr square down the moment of inertia, because moment of inertia also contains mr square. So is a very good ratio. This also contains mr square in some form, is equal to what? mg sin theta. तो अब ये m और ये m खत्म हुआ, तो मैंने निकाला एक्सेलरेशन इज इक्वल टू g sin theta बाय 1 प्लस I बाय mr स्क्वायर. ग्रेट फॉर्मूला. देखिए, मैं आपको समझाता हूं. When a body rolls down the incline, it may be a cylinder, it may be a sphere, it may be a disc, it may be a ring. What is the acceleration along the plane? Down. G sin theta, as you already know. But now, if it's a rolling body, a body which has a rolling tendency, maybe a ring, maybe a sphere, maybe a disc, a hollow cylinder, a hollow sphere, then what you have to do? G sin theta remains there as it is. Divide करना पड़ेगा 1 plus I by mr square. Suppose it is a disc rolling down. Disc का ये moment of inertia यहाँ लिखो, that is what? 1 by 2 mr square. तो यहाँ 1 by 2 mr square लिखोगे, mr square gets cancelled, is 1 by 2, that is 3 by 2, 2 ऊपर जाकर 2 sin theta by 3 आंसर आएगा. So it is a great formula and easy one. Let me go to the next problem. Last one. This is the 5th problem. The problem is like this, because I have already told you the present lecture is conservation of rotational energy, conservation of total energy, and it is all deals with the energies. So here is the disk. It is a disk here. It rolls, having a velocity of the center of mass as v. It rolls and this goes up the incline. It goes up the incline. लेकिन incline जाते जाते ये थक जाएगा. It will get tired and finally it will stop. We have to see why it will stop, at what height it is going to stop. Obviously, where it stops, the total energy is 0. I'm sorry, the total energy is total potential energy. Rotational energy will be zero, all the kinetic energies will be zero, but it will have only a potential energy, that is E2 is equal to mgh. This will be its energy here when it stops, because when it stops, it is V will be zero, its omega will be zero. Why? Because V is equal to R omega. Body is rolling. When it stops rolling, both the things will have to be zero. V is zero and omega is also zero. Right? Okay. Now what is the energy here? E1. That is 1 by 2 mv square plus 1 by 2 I omega square. What is E2? When it goes up and stops there at some point, that is mgh. So according to conservation of energy, क्या लिखेंगे? Using conservation of energy. Energy has to be conserved. पहले जो इसका एनर्जी था kinetic, translational and rotational, it goes and slowly goes up and up and up and up and stops, and all its energies have been converted to potential energy, because by that time it is all this kinetic energy has exhausted, but at the same time that energy has converted into potential energy. So final energy is mgh, potential energy. Okay, now we will write E1 is equal to E2. E1 is equal to 1 by 2 mv square plus 1 by 2 I omega square is equal to E2 is mgh. Right? Okay. Now I will, because I have to get the answer in V, not in omega, and I will substitute for I also, because it's a disk, that is known fact. It is a disk, and I know what is the moment of inertia of a disk about the center of mass axis. That has to be substituted. So what should I write? It is 1 by 2 mv square plus 1 by 2 I, that is 1 by 2 mv square. Sorry, 1 by 2 I omega square. No, moment of inertia की बात कर रहा हूँ. Sorry, moment of inertia I, that is 1 by 2 mr square. Omega square is V square by R square, because it is rolling, and we know for rolling V is equal to R omega. Right? So is equal to mgh. ठीक? तो ये खत्म हुआ. 1 by 2 mv square, 1 by 4 mv square, that is 3 by 4 mv square is equal to mgh. m खत्म. Right? तो मुझे बताइए how much height it will go up? h. That is 3v square by 4g. That is the answer. So if it is moving up with a greater speed, it will go to a greater height before it stops. These are a few examples on rotational energy and conservation of energy. And I will continue a few more lectures on these problem sets, and finally I will start, after this I will start gravitation with the students. Thank you.